Hello everyone. So today we're going to talk about a new notation for derivatives. Okay, so we're going to talk about what's called Leibniz notation. So before, when I started introducing the derivatives section, right, so in Unit 2, I told you that Isaac Newton created calculus, which he did, but there was also another mathematician that did create calculus at the same time, and so the mathematician's name is Leibniz. So here, Leibniz had a different notation than Newton for the derivative. And so I just explained that given a function y equals f of x, the Leibniz notation for the derivative f prime is dy dx. Okay, the derivative of the function y with respect to the x variable. Okay, so what the dy dx means is the numerator is basically just telling you to take the derivative of the function. In this case, the function is the y variable. Okay, and then the denominator tells you to take the derivative with respect to which variable. Okay, so our function was like y equals and then a bunch of things in terms of x, that variable x. So that's why it's dy dx. Now in single variable calculus, it's not as important that we use Leibniz notation as it is in multivariable because we only have one variable, hence the name single variable calculus. Whereas in multivariable, we have, of course, multiple variables. And so it is more clear using Leibniz notation, like to use, like what variable am I taking their derivative with respect to? Okay, but it is also a great notation for us later when we talk about implicit differentiation. So that's why I do want to introduce you to the notation, mostly for that, but also just so you're aware that there is two notations for the derivative. And so you will see that in future mathematics courses and also in this course. Okay, so additionally, we write dy dx with a bar, x equals a, to just represent the derivative at a, or the evaluation of the derivative at x equals a. Okay, and then last but not least, we have this notation here, d dx, which basically just means to take the derivative of the expression with respect to the x variable. Okay, so you notice that in the numerator, it just has the d, but it's missing like another variable. Like up here, we had dy, right? That's because we had a specific function that we were taking the derivative of. In that case, the function was y. But here, when we're just taking the derivative of an expression, we don't have like a specific function we're taking the derivative of. So that's why it's just d over dx or d dx. Okay, so now that we've introduced Leibniz notation, I'm just going to talk to you about the specific derivative rules. So we have 4 as of right now. There will be more. But basically, rules 2 and 4 just come from the rules previous, the ones right above them. So I will explain to you, right, in rule 1 what this means. So here I'm just telling you how to take the derivative of an exponential function. So the derivative of a to the x is just ln of your base times itself, a to the x. So just looking at an example will be a little bit easier. So this is like, what's the derivative of 2 to the x? So the derivative of 2 to the x is just 2 to the x times ln of my base, which is 2. Okay, but now in rule 2 here, we have that our example is to take the derivative of e to the x, and this is students' favorite one because it's just itself, or e to the x. So there's not too much to remember there, but here I'm just going to show you where that comes from. So if I'm taking the derivative of e to the x using rule 1, I get that this is e to the x times ln of e, and ln of e is just 1. Okay, so that's why we say that the derivative of e to the x is just itself e to the x, and so I'll just tell you here this is by rule 1. Okay, Now, rule 3 is just telling you how to take the derivative of logarithmic functions. So if you have log base b of x, the derivative is just 1 over x times ln of your base. So given an actual example here, the derivative log base 2 of x is equal to 1 over x times ln of 2. Okay, and so rule 4 here is just saying a specific rule for the natural log of x. So the derivative of the natural log of x is just 1 over x. And where that comes from is from rule 3. So here I will just show you that this is ln of x. The derivative is just equal to 1 over x times ln of e, because our base, remember, is e. But again, this is just ln of e is just 1, so this is 1 over x.